You would think in today's high-tech world of computers, satellites, and fiber optics that our schools would be equipped to prepare us for the challenges of the 21st century. Hi, I'm Kenan Cisco.
And I'm Omar Popol. Most schools today haven't changed much in recent years. Not exactly what I'd call our classrooms of the future.
Wow, classrooms of the future? Think about it. Computer workstations instead of desks, online databases instead of libraries, communication links to interact with students at other schools.
Sounds pretty cool, doesn't it? Well, thanks to Challenger Center for Space Science Education, students all across the United States and Canada are experiencing the future today.
3, 2, 1, we have liftoff.
To make sure students don't feel like they're just in another classroom, Challenger Center modeled its learning centers after NASA's Real Mission Control Room.
And this learning laboratory is modeled after a working space station. Talk about an awesome science lab. When students come through that airlock, they become real scientists and engineers.
Mission control for the space station, the message from the ISO team. The mass of sample number 4 is 81.7. Over.
And through the magic of technology, students get involved by performing hands-on experiments and activities, and then sharing that information with Mission Control through an electronic link.
Space station, this is Mission Control. We acknowledge. Good luck. Over.
The Challenger mission is to explore, to inspire, to learn. The Challenger 51L mission continues because we provide programs for youngsters. Youngsters that climb aboard a space station, fly a mission. They learn how to conduct scientific experiments. They learn life skills as well. They learn how to solve problems, work together as a team, and they're excited about working with math and science. And the Challenger crew itself was a unique crew, representing all races, all cultures, religions. And the team that joined the family team to build the Challenger Center represented all walks of life across our country. Challenger Center is continuing to grow. Programs are located all across North America. They're set up in university programs, in museums and science centers, so it's a great opportunity for youngsters to learn.
While space science is the primary theme of Challenger Center mission simulations, the real lessons are learned by working with teammates to figure out solutions for challenges that pop up during the mission. Pro team, we've got a problem. This circuit looks like it's faulty. Over.
The computer file suggests using two 5-amp boards to bypass the faulty one. Over. Not only are key life skills an important part of every mission, Challenger Center's programs allow students to touch and feel the world of real scientists and engineers.
25 degrees latitude and 90 degrees longitude.
Placement number 2 was bad.
When the kids come in here to the Challenger Center, I'm sure they've had, some pre-briefing. But I don't think that they are fully prepared for the visual effect and the stimulation that they will receive when they sit down and they are perhaps a commander, perhaps a mission specialist, perhaps a flight doc or something of that nature. And they will see something and experience something that they perhaps read about but could not truly appreciate until they came and experienced it. The Challenger Center takes the concept of space flight, the excitement of it, the theory of exploring and discovering, and by having students come in and work in an environment such as that, the students will come out with a much greater understanding and appreciation for the rigorous activities of the science, math, and engineering, and they can put it in some concept that they understand and perhaps might be motivated to pursue as a career.
One thing that hasn't changed in Challenger Center's futuristic classrooms is the focus on academics. After all, it's still a classroom, and we are here to learn.
Like any real scientific undertaking, the work begins long before the actual mission. Teachers receive pre-visit and post-visit materials, and in many instances, in-service training to help them prepare their students for a flight inside of a Challenger Center simulator. Depending on the theme of the mission, students use traditional classroom activities to study about comets, planets, the moon, the Earth's atmosphere, and more.
One of the things that we take a lot of pride in at the Challenger Learning Center and realize is critical to the success of the mission is the training of the teacher. So as we get involved with teachers, we bring them in for extensive pre- and post-flight training so that students just aren't seeing this as a field trip, but instead we're building our program into curriculum centers across the United States so that teachers are actually not seeing this as an add-on, but an add-in to the current curriculum that they're using. Simulations are fun. When you have excited students and teachers working together, especially in the fields of science and math, you have a key to success.
It's not just the technology that makes a classroom of the future. It's an entirely different approach to learning. It's a classroom where teachers serve as facilitators and encourage students to learn through discovery.
And where students actively participate in the learning process, as opposed to just taking notes and memorizing facts.
And Challenger Center offers other programs like Mars City Alpha and Marsville, so any classroom or school can touch the future by tapping the power of a child's imagination. Both of these award-winning programs use simulated missions to teach teamwork, communication, problem-solving, and decision-making.
While at the same time sparking students' interest in science, math, and technology.
After all, we represent tomorrow's scientists and engineers.
Classrooms of the future are becoming realities today. Not only are Challenger Center programs bringing learning to life, they are changing the way teachers teach and students learn.